Okay, so for problem, for example 9.7, we have here this picture which is basically about a cable being wrapped around this drum that we have here, and we're told that it unwinds without slipping, and the cylinder is going to be initially at rest, right? So it's asking us to find the angular velocity and the final speed of the cable, right, when when it's being unwind and stuff like that. Okay, so how are we gonna go about this? So something important to know: we're gonna need all this information. We're gonna need the information that's shown here. That's where I'm gonna be getting the information from. But we're also gonna need to know that the radius is 0.06 meters. So that's also important to know. Okay, so first we're trying to find angular velocity, right? So we're gonna have to try to use an equation where we have angular velocity. So we can use kinetic energy, which is half of the moment of inertia, and the angular velocity squared. And we know that this is equal to the work that's done in this situation, which is also equal to the force times the distance that it gets unwinded. Okay, so we have some of that information. We know that the force is going to be 9 right? The force times the distance done unwinded is going to be 9 newtons, right? With this we got it from the picture, times 2 meters that it got unwinded, which we also got from the picture, and that gives us 18 joules, and that's going to be the amount of work that's done. So now we have that work, right? And now to find out what is the moment of inertia, which is what's needed here, right? We know that the moment of inertia is equal to half times the mass times the radius squared. So we have that information. We know that half times 50 kilograms times the radius 0.06 squared, that's going to give us 0.090 kilograms by meter squared. That's going to be our moment of inertia. So now we have basically all the information we need that we can use to solve for the angular velocity. So we have the 18 joules, which is what we solved for before, and we got the moment of inertia, which we solved here before, and we're using this formula basically right there from that equation. We solve for angular velocity and we get it's 20 rads per second, right? That's going to be the angular velocity, and then it's asking us to find the final speed of the cable. So basically it's asking us for velocity. So to do that, we know that we can use velocity tan, v tan, the component tan, and that's going to be equal to the radius times the angular velocity, and the radius is going to be 0.060 times the 20, which we got from, that's the angular velocity which we got from before. We multiply that and we get 1.2 meters squared, and that's our velocity.